Hello. For this problem, the empirical rule tells us that 68% of the data is within one standard deviation. Depending on, this is a sample, this would be population. So symbols depend on if it's a sample or a population. So I put both symbols there. But you add and subtract the standard deviation. 95% of the data is within two standard deviations. So you take 2 times the standard deviation and add and subtract it from your mean. And then 99.7% is within 3 standard deviations. So for this problem, for a 4-unit class like statistics, students should spend an average of 12 hours studying for the class. A survey was done 23 students, and the distribution of the total study hours per week is a bell-shaped with a mean of 13 and a standard deviation of 3.2. So 3.2 is our standard deviation, 13 is our mean. Use the empirical rule. While 68% of the students are within one standard deviation. So we take our mean, 13, minus 1 times the standard deviation, which was 3.2, and 13 plus 1 times 3.2. And when you calculate that, you get 9.8 and 16.2. So 68% of the data is between these two values. For the 95%, again, we take our mean, 13, minus 2 times the standard deviation, and 13 plus 2 times 3.2. And we get 6.6 and 19.4. So you're just subtracting and adding the standard deviation, and it's either times 1, 2, or 99.7% of the data is within 3 standard deviations. So we take our mean, 13, minus 3 times the standard deviation, and 13 plus 3 times 3.2. And we get 3.4 and 22.6. And so that's what your data is between. If you wanted to look at the bell-shaped curve, because it says it's a bell-shaped curve. The mean goes in the middle, which was 13. Now this first standard deviation is 68% of your data. 68% of our data was between 9.8 and 16.2. If we go another one, from here to here is 95% of our data, and then value is 6.6 and 19.4. And then going one more, is the 99.7. So almost all of our data is in those two values, which were the ones we got last, 3.4 and 22.6. We leave 0.3% for values that are outside that, outliers. So that's where those values are coming from.